And good morning, it's Jim from the maverickstar observatory. Guys, as you know, it's the 17th of the month, and on this day we pull the SD card out of the TriMag. Have a look how that has been going. We also pull the SD card out of the Magnetosphere sensor, do the same with that, and we also locate the magnetic North Pole and mark its position on our Google Maps so that we can keep track. If you're interested in following this, you'll see the longitude and latitude. It's at 83 degrees north by 43 hours 45 minutes and 73 seconds. The longitude is 126 degrees east by 237 hours and 86 minutes. So that's the position if you want to log it on your maps if you're following it. Let's just have a quick look at where the vicinity of the magnetic North Pole is. So if I just remove this for us and zoom out, we can see just roughly where we are. By the way, we've moved 4.15 miles since we last took the reading last month, so it's migrated towards Siberia by another 4.15 miles, so still heading towards Siberia progressively. And if we zoom out, we'll see just how far away we are from that all-important 40-degree mark. So we'll just do a quick measure just to find out how far we are away from there. So around about there to there puts us about 143 miles away from the 40-degree mark, and it is at that point where it is anticipated we will leave the strong field lines of the poles and go into the weak field lines, and at that point we could see the poles go into the full reversal, or even if it's an excursion, we should start to see some activity. I would hope to see it before we get to that 40-degree mark, but certainly when we surpass that mark we should start to see a lot of activity with our magnetic poles. That puts us about 3 to 7 years out, give and take a couple of years. It could happen in 3 years, it could happen close to the 7, but that gives you an idea of where we are. And just if I zoom out from here, we can see where that 40-degree mark is and all the other pins that have been put in over the time, where Siberia is and where it's migrated since the 1900s. As you can see, it has covered a lot of distance, and in that time that it's been covering that distance, it has moved up in speed at least 2 or 3 times. And when we have a look at the TriMag data a little bit later on in this video, we'll see how it has changed and covered more distance in short spaces of time. So we're at a point where things are gearing up to start happening, and it is anticipated it'll be about 3 years away before we start to see that activity really starting to show. But as well as monitoring the position of the magnetic North Pole, we also monitor the field intensity strengths at different locations of the world, and we're going to have a look at Perth's data as well as our own magnetosphere data here in the UK, and just see how that's been migrating a little bit later on in the video. But before we get into any other discussions on the data that we've collected, I'd just like to say a big thanks to all those people that support us on Patreon. And if you're looking at on Patreon, you'll see that the numbers are slowly dropping off, and I put that down to what has taken place with COVID-19. We are starting to see a slowdown of the support that we're getting. I'm not surprised. At the moment charities around the world are suffering, and as a result of that we're seeing them on the TV, and I'm not surprised a few people are getting a little bit annoyed with people asking for funding, and funding is dropping off for them just as much as it is for us at the observatory. But if you just listen in the background to the CPU fan kicking in on this computer, we desperately need to do something about that and improve it. And I says I wanted to do live broadcasts, but I can't until we raise the money for that new computer for the observatory. And the reason for that is because the graphics card on this computer just isn't up to the requests that we're putting demand on it right now, and that's why the CPU fan is always kicking off in the background. It's obviously become a little bit famous on these videos, and I've had a lot of people mention, about it. But we're trying to run graphics on the 3D CAD design, slows the computer down. We're trying to run OBS on there, and we're lacking the graphics card to run more than one screen, and that would enable us to do live broadcasts and just become a little bit more professional with a few other things. And we're just being set back all the time by dwingling support. I want to just make a big thank you to a special few people, and if I don't mention your name, it's not that I don't genuinely respect the help that you give the observatory over the past. It's just that we do have a couple of superstars that constantly there supporting us with more than just a couple of bucks, and therefore I think it does warrant a big shout out to these people. So starting first with Doug, Bob and Kathy, you have given us endless support for nearly a year now at the observatory, and you pretty much single-handedly, along with Susan, who's also been supporting us regularly with considerable donations. Without you guys, it just simply wouldn't be possible to do what we're doing. I mean, today we've put 4 or 5 hours in sorting out data from Perth, Australia, the Magnetosphere sensor and the TriMag, and in this video we'll look at CO2, oxygen levels, we'll give you the muon rate counts, as well as what else? Yeah, like I say, CO2. So it's quite a lot of data that we're collecting off the equipment, and none of this is speculation. This is all based on the data that we've collected, and therefore fact. So I just want to say a big thanks to you guys for your support, and if I can encourage a few other people to come forward and help us during this time, it would be greatly appreciated. So let's have a look at the data then from the TriMag and the Magnetosphere sensor that we've collected here at the observatory, and then we'll go over to have a look at the data that one of our superstars have sent us from Perth, Australia, and we'll just make some comparisons on that data that we've collected. So just before we look at the last month's worth of data that we've collected here at the observatory with the TriMag system, I just wanted to show you, this is the map on how it's been progressing. You can see when it jumps up, like this, almost exponentially, you can see that there has been a lot of distance covered in a shorter space of time. If we just look at how many miles it moved since it very first started to migrate to 1990, here we can see it moved 500 miles, and from 1990 to 2020, it's got to be updated, this chart has, to 2020, but you'll see it's covered over 1,000 miles since 1990 to 2018. 28 years later, it's covered 1,000 miles, as opposed to the time in 90 years from 1900 to 1990 only moving 500 miles. So it just shows you how fast the pole is migrating, and that it is not impossible for it to do this again. We have seen it, like I say, do it 3 times at least, jump up a gear and cover more distance in a shorter space of time. So looking at the TriMag data that we've collected over the last month, we can see again it is buffeting really close on 13 degrees. We calibrated the TriMag at 10 degrees and it is now very close to 13 degrees. 1291, it does sometimes hit 13 degrees. It hadn't in this time or last month's recordings, but this is a very slow progressive migration that we're looking at, and in total it only moves around on average 4 miles every month. If we compare that with just a few months prior to that, we can see that there has been something unusual happen. We have this like sine wave appear for the first part of the month and then goes quiet, and then we have a little blip where there's a little trough, and then this sine wave reappears back again. So again, here we can see that there's a blip, and here's a blip, and then calm, and then there's another blip again. So there has been some activity. We're not quite sure what causes this. One thing for sure is we're not seeing those magnetic spikes like we was over the northern hemisphere, where we get like a real sharp like needle in the chart reading. That seems to have calmed down a little bit, but nevertheless the magnetic north pole is still tracking towards Siberia at a constant speed, and the distance is on or around 4 miles every month, and still heading, as I say, towards Siberia. Let's have a quick look at the magnetosphere data over the last month. What we can see is a slight increase from the beginning of last month's reading. It seems to be a trend that we're seeing not just on our magnetosphere but on a few others. If we have a look at maverickstar global data, Perth, Australia's data has recently been added this morning. We can see that there was a sharp increase in the data from Perth, and I'm not sure whether that's because the magnetosphere has been knocked, or it is, as we see, a great increase in the data. But we are seeing a slight increase from Hong Kong, and we have done in Arizona as well. So we could see our magnetosphere in general slowly increasing, which is bizarre because you would expect it to do quite the opposite, as the poles are still migrating. So we don't quite know what it is that is influencing the magnetosphere at the moment in these locations where we have these magnetometers, but the data that we're getting back is what we are recording, and we are showing you what we get. But if this is true, there has been a sharp uptake in microteslas, and when you're given the fact that our Earth's entire field strength is about 48 to 58 microteslas, when you see a jump of 2 or 3 microteslas, that's quite a lot. Because if you put that into context, it's around 5 to 10% of the entire field strength. Radiation in this region, as you can see, it's at 0.013 microsieverts per hour, which is below normal. We've got atmospheric oxygen just at 20%, just under 21%. You can see it's 20.95%. It's the figure on the bottom there. The other figures that you've got on the screen above the bottom figure are temperature, atmospheric pressure, and sensor pressure inside the sensor. And then surprisingly, guys, our CO2 parts per million is at 430, despite nobody using the cars over the last several weeks, or 90% of the world's combustion engine burning fuel engines are not running. We've still got 430 parts per million. Again, as I said last time in the video I done, when I showed the CO2 parts per million, this is a slap in these climate extremists' face. How dare they tell us that humans are driving up the CO2 in the atmospheric reservoir, when we can clearly see that when 90% of the world's engines, ships, aircraft are not in the skies polluting with CO2, the CO2 levels are at the exact same. It's just it's a con, isn't it? And we all know that, and this is just proof of it. And this is what I'm always saying here at the observatory. We can check atmospheric oxygen levels, we can check CO2 levels, we can check the radiation. And by the way, before I end this, the muon count has decreased surprisingly by 20%. That means the parts per muons per hour per square metre are at 412, when they're usually just over 500 and sometimes creep up to 600. So we could say we are more than 20% receiving less muons, which means that's less interactions with cosmic rays in our upper atmosphere. For some reason they're 20% down, but that could be to do with that we've had a couple of microteslas increase in the magnetosphere sensors at different locations, as we've picked up. There has been a slight increase in Arizona, Perth, Australia, and Hong Kong, and here at the observatory in the UK. So we are seeing a slight increase in that, and that could be giving us a bit more protection from the cosmic rays, and that's not a bad thing. But what's caused this is, what we're trying to investigate. Because if we can say, by a 2% increase of the magnetosphere strength results in 20% less muons, that's a good indication for future. If we're just watching muon rates, we know what's going on with the magnetosphere, or if we see the magnetosphere increase by 2 microteslas, we can say that that's going to relate to 20% decrease in muons. So it gives us a good gauge of, making predictions. And that's why we do what we do here at the observatory. This is the sort of information we don't get from these mainstream organisations, and it's only by, using the equipment that we get to find out these answers. These answers cost money to answer, guys, one way or another. We wouldn't know what the CO2 was doing if we didn't buy that equipment. We wouldn't know, for truth, for accuracy points of view, what the atmospheric oxygen would be doing if we didn't have that state-of-the-art oxygen sensor in that unit. And that's the same for this. If we never had the Geiger counter, we wouldn't know what the background radiation was. If we didn't have the muon detector, we wouldn't know how many rates of muons we're getting in the atmosphere. And, we wouldn't know what the condition was with regards to the cosmic rays coming through our atmosphere, interacting with the upper atmosphere and banging into, other air molecules, creating muons. We wouldn't know. If we never had any of this equipment, we would not know. And we would just be guessing where the magnetic North Pole was if we didn't have the Trimax system. And it's only because we've got this equipment we can answer these questions, or try to answer these questions based on facts. And the only way we can do that is by having the equipment and recording the data. And that's how we get, the information back accurately. Not making speculations, but, by using this equipment, collecting the data, we're able to get facts. That's what's important right now, guys. We live in a world where a lot of people, as you may well know, on YouTube, we live in a world where, there's a lot of speculation. And people, just go with the speculation. And that's the world we live in. It's frustrating when you try and explain to somebody, look, if you want to really know the answer to a question, then, you've got to put your hand in your pocket. And, you've got to lay out a little bit of cash, unfortunately. If you want to know how many parts per million of CO2 is out there in the atmosphere, then you've got to buy a CO2 meter to find out that answer. So you have to spend a bit of cash. It's really frustrating when people ask me questions. They're not that concerned to spend money in order to get the answers. So where does that leave them? If they're not prepared to spend the money, they're not going to get the question answered. And that leaves them with whatever the mainstream media tell them. And that's where all this speculation comes in. It does get frustrating, but there you go. Well, guys, that's a wrap. That's your muon rates, your oxygen rates, your CO2 rates, your radiation, at least in this location. That's the position of the magnetic North Pole. And, you've had a look at the magnetosphere data that we've collected here at the observatory in this region, and also from Perth, Australia. So, again, big thanks to all those people that support us at the observatory. We try and answer the questions based on facts here, and the only way we can do that is by investing time and money in building the equipment, buying the equipment, and bringing that information back to you guys. So I really appreciate the few that stand with me on this and support what we do here at the maverickstar Observatory, and I just want to thank you once again for that. If you want to join us here at the observatory and help us at this time, which is very frustrating, because COVID-19 is slowing everything down, there is a link there that you can do it. It's not mandatory, by the way. I just want to make that clear. And we certainly do not beg here at the observatory for people to support us. We ask for the support. It's a bit of a difference. And, it's not like we're standing there with a cup in our hand, shaking a couple of coins in there. We do build and buy the equipment to answer those all-important questions for us. Okay, I will leave you here, guys. I am planning on doing a video later on. If you want to, tune back for that. It isn't related to any of this, or not directly related to all this that we've discussed in this video, but equally I think it's important. I think it will shock you what we're going to be talking about later on in the video, because it's nothing short of a scandal what's going on right now. And I'll just give you a little teaser on that. 63 people 63 of the most richest people in the world, are receiving bailout money by the British government. And half of these companies that these people represent, these are in a lot of the cases billionaires, but half of them haven't paid any taxes for many years in this country, and yet they've been bailed out. And that should make people very angry, because there's a lot of us that haven't benefited at all or received any support whatsoever during these last 7 weeks. And there has been a lot of companies worldwide go bankrupt, and it's not, I don't think that this is just something that's related to the UK. I think this is something that's been reflected around the world. It seems that the rich people have been feeding from the taxpayer's purse, and they say we're in a free market, but this is a conversation I'm going to have in this later on video this evening. I'll put that up, so join us. So okay, link down there if you want to help support the observatory. You can see what we do, and you have a good day and take care of your loved ones. As always, bye for now.